Hey everybody, this is Greg. How are you? It's a beautiful Sunday evening in Oregon, and we actually got 2 really hot days. It felt so good. We'll see what the week brings, but got a little time on my bike. It felt very good. So this is our week 3-4 transition, and first of all, week 3 I believe went well. Your operationalizing of your constructs was fine. I appreciate that. I have to look at the surveys yet, but I'll have that done tomorrow. But week 4 becomes a little different. Week 4, 5, 6, and 7 are the real heart of the quantitative course. And let me explain. Up to now, your answers have been very good, but they've been general in nature. From now on, the solutions to the questions need to be reasonably specific. So let's talk about the week. First of all, there's 3 things that have to be done this week. There's the writing different hypothesis assignment, there's the choosing a research design assignment, and then there's the group sampling activity, which is due Thursday. So let's talk about the writing different types of hypotheses first. Now, I sent you 2 documents a week ago, and if you don't have those, I'll send them to you again. Writing hypothesis is not a creative exercise, and it's probably the part in the textbook that is the weakest. There are very standard formats for writing hypothesis in quantitative research, and remember, there's only 2 types of hypothesis. There are null hypothesis and alternative hypothesis. A directional hypothesis is a type of null hypothesis, not a third type. So let's run through an example of each. A good null hypothesis is there is no correlation between height and IQ as measured on the IQ scale. That's it. That's a null hypothesis. The alternative hypothesis is that there is a non-zero correlation between height and IQ. That's the alternative hypothesis. So that's an example of a correlational design. People tend to state things in hypotheses like there is a really good relationship between the amount of time a student studies and their grades. That's not a null hypothesis. That can't be tested with a correlation statistical test, and it can't be nullified with a low p-value. Another example would be there is no difference in the mean test scores of the 8th graders who have studied with a teacher who is constructivist in nature and the test scores of 8th graders who have studied with teachers who are not constructivist in nature. So there you're comparing 2 groups. And so the null hypothesis is always that there is no difference and no correlation, and you have to be very specific about what 2 variables you're comparing, 2 means or the correlation between 2 things. So the alternative hypothesis is always the negation of the null hypothesis. So the alternative hypothesis would be there is a difference in the mean score of students who have been taught with a constructivist approach and students who have not been taught with a constructivist approach. So I want you to follow the formats of the hypotheses that I sent you and that I outlined, because that's the way they are in all quantitative research, and there's not a lot of room for differentiation here. And it's important to go by that format. The tendency of people is to try and make more out of the hypotheses than possible, and to add to it, maybe to get a better score. But if your hypotheses are correct, then you'll get full credit. But it's important to be able to understand how to write a correct null and alternative hypothesis. So if you have any questions before you submit the assignment, feel free to contact me. I'll be available every night this week. But I really would like to talk to you before you submit them, so you don't submit something that isn't quite technically correct. The next topic is choosing a research design. Now, in this week, here's where people tend to really make some mistakes. In educational research, there are only 3 or 4 real simple quantitative designs. In experimental psychology, if you were getting a PhD in psychology or something, it would be much more complex. Plus, you'd be taking about 5 very complex statistics courses. In educational quantitative research, you can read all kinds of research papers, but at this level, you're primarily limited to correlational design, which means you're correlating 2 continuous variables. Study time and GPA, or amount of time spent at home in a quality environment with your IQ, and both variables can be measured continuously. You can't correlate whether you drive a Ford pickup or not and IQ. That's not a correlation. The other type of quantitative design is called causal comparative. That's where you're comparing 2 groups. So you're looking to see if there's a difference between the means of 2 groups or the difference between the proportion of 2 groups. Is the proportion of 8th graders in Kansas who have passed the state assessment higher or lower than the proportion of students in Nebraska that have passed the state assessment? So you're comparing 2 groups. Now, you don't know the cause of the difference, if there is, but you're still, that's why it's called causal comparative, because it's ex post facto. You're not manipulating the independent variable. So that's a causal comparative design. The third type of design, which is really not a difference, is when you compare 3 groups with a one-way ANOVA. So you're comparing 3 groups for 1 independent variable. You're looking at students who have been taught one way, students who have been taught a second way, students who have been taught a third way, and you're looking to see if there's a difference in their mean state test score or something like that. So the tendency of students is to send in complicated research designs that they get out of a text, but that they really aren't crystal clear. So I want this to be accurate, to the point, and I want to help you so that you do it correctly, so that when you get to writing your dissertation, you can explain exactly what you're doing to your committee. So I want to make sure that I help you with this week, and you can contact me before you submit any of these assignments, and they are due on the regular date. Now, the last activity is the sampling activity, and here's a few points on that. When you sample something, the very best sample is a select random sample of which every item has an equal chance of being selected. So if you're going to find out what candidate people support, you need to have an equally likely chance of picking everybody in the United States. That's the best sample. That's always the best sampling technique, which is a pure random sample. A cluster sample is an inferior sampling technique, because then you're only taking a subsection of a population in which your results are going to be skewed. But sometimes you have to do that. Sometimes the only thing you can sample are Mrs. Jones' 8th graders, not all of the 8th graders in the school. So on the sampling assignment, just be very specific. Exactly how are you going to randomly choose elements of the population for the sample? That's what we're looking for here. So I think we're doing really well up to now. So as the course goes on, the responses are going to have to be a little more specific and precise as I'm leading you up to the final project, which is the vast majority of the points, and there's a lot of information that needs to be gained before we do that. So I'm available all week, and I've finished teaching my other college classes, and high school is still busy, but I have a little more time in the evening. So anything I can do to help you, I certainly will, and let's have a good week. Okay, thank you. Bye.